Hi there and welcome to the video. In this video we are going to look through drawing and interpreting some probability trees. We are going to focus on the idea of dependent events, of dependent probability. So that will just make our probability trees that little bit more complex, that little bit more difficult. First thing we need to know is the definition of a dependent event. So the definition of dependent events is that what occurs in the first event affects the outcome of the following event or the second event. So the outcome of the second event is dependent on the outcome of the first event. Let's have a look at a few examples of that and see if we can try and understand how we could put that into a probability tree diagram. Here's a very typical question. You have 8 chocolates in a tray. 5 of the chocolates are milk chocolate. The rest of the chocolates are dark chocolate. If you select randomly and eat 2 chocolates, what is the probability that you will eat 2 dark chocolates? And we're being asked to complete a probability tree including all the calculations. Okay, so first of all, we've got 2 possible outcomes. We have got 8 chocolates in this tray of chocolates, and 5 of them are milk chocolates. So the probability of choosing a milk chocolate for the first pick, for the first chocolate, is 5 out of 8. And the probability of choosing a dark chocolate would be 3 out of 8, because that's how many's left over. These 2 branches of the probability tree always have to add up to 1 whole. So they add up to 8 out of 8, which would be 1 whole. That's all straightforward, really. We've got 5 milk chocolates, which is why we've got 5/8 here. And the rest of them are dark chocolates, which gives us the 3/8 here. That would be our first choice, the probability of choosing a milk or a dark. What becomes a little bit trickier to understand is when we look at the second selection, the second chocolate. So this is what my second selections would look like. So you can see that the probabilities on each branch of the probability tree, they change slightly. Let's have a look at why that is. The probability of choosing a milk chocolate on my second choice is 4 out of 7. And that is because previously this had occurred. So I started with 8 milk chocolates and I chose a milk chocolate and ate it. So then I had 1 less milk chocolate and 1 less chocolate altogether in my tray. So the probability on this branch is affected by what took place on the branch preceding it. If I was to eat a milk chocolate, the probability of choosing a dark chocolate, the numerator would still be 3 because I still have 3 dark chocolates in the tray, but I have 1 less chocolate altogether because I ate a milk chocolate. So that's where my probability of 3 out of 7 comes from. Again, them 2 add together to give me 1 whole. The other option of what could have happened first was that I could have chosen a dark chocolate. So let's assume that I did choose and eat a dark chocolate. So for my second option, my second pick, the probability of choosing a milk chocolate, I still have 5 milk chocolates, but I have 1 less chocolate in the tray altogether. That's where my 5 out of 7 comes from. If I was to eat a dark chocolate, I started with 3, so I now only have 2 dark chocolates, and I've got 7 in the tray altogether because I've already ate 1. So again, this probability is affected by what happened on the first pick, what happened on the previous branch. So this probability is dependent on what occurred here. The question does ask me to complete all calculations, so I'm going to go ahead and complete all calculations. I'm going to follow the branches. 5/8 multiplied by 4/7. That's going to give me a probability of 20 out of 56. So the probability of choosing a milk chocolate for my first chocolate, then a milk chocolate for my second chocolate, is 20 out of 56. 5/8 multiplied by 3/7. That gives me a probability of 15 out of 56. Probability of choosing a milk followed by a dark, 15 out of 56. I could have chosen a dark first, followed by a milk chocolate. That would give me a probability of 15 out of 56 again. Or I could have chosen a dark chocolate and then another dark chocolate. That would give me a probability of 6 out of 56. What the question actually says is, what is the probability that you eat 2 dark chocolates? So now I go to my probability tree, dark and dark. So this is the probability that I'm interested in. I could simplify it down to 3 out of 28. I've highlighted the route I've taken on the probability tree to answer the question at hand. So just make sure you double check the probabilities on the second event and make sure you understand that they are influenced by what has happened previously. They are dependent on what has happened previously. Let's talk through another example. Dan has 12 playing cards in his hand. 5 of the playing cards are red, the rest of the cards are black. So I already know he has 7 black cards. If you select randomly 2 cards without replacement, what is the probability you will choose 2 cards of the same color? This bit here is very important. You'll see that in a lot of exam questions. Without replacement. So I'm picking a card and I'm not putting it back in the pack, which is telling me I'm dealing with dependent events. I'm dealing with dependent probability. The second event is influenced by the card I will have picked first. Let's go ahead and try and draw a complete probability tree for this question. My first event is choosing either a red card or a black card. Probability of choosing red is 5 out of 12 because I've got 5 reds and 12 altogether. Probability of choosing black is 7 out of 12. I've got 7 black cards and 12 altogether. That's all quite straightforward. We're just setting up a couple of fractions that display this information. When it becomes a little bit trickier is when we look at drawing the second card, so the second event. So this is what our branches would look like. So up here, if we chose a red card on our first pick, then we would only have 4 reds left and 11 cards left altogether because we're not replacing the card that was picked in the first event. If I chose a red for my first event, the probability of choosing a black card on my second event would be 7 out of 11. 7 because there's still 7 black cards involved, but 11 because I've got 1 less card in total because I've took 1 red out of the pack. So both of these add up to 1 whole, and both of these probabilities are dependent on what occurred here. The other option I have is that I chose a black on my first card. My first pick was a black card, which now means for my red probability, I've still got my 5 red cards that I started with, but I've got 11 altogether because I lost 1 from the pack. If I was to have chosen a black card, then my second probability for a black would be 6 out of 11. 1 less black and 1 less altogether. Those two add up to 1 whole and are both influenced by the selection, by the pick I had on the first event. You can see that the probabilities for the second choice of card are all affected by what happened from the first event. I'm going to go ahead and work out some probabilities. To choose 2 reds, it would be 5/12 multiplied by 4/11, which would give me a probability of 20 out of 132. The probability of choosing a red followed by a black would be 5/12 times 7/11, which is 35 over 132. I also have an option of choosing a black card and then choosing a red card. Probability of that would be 35 over 132. And I also have the option, the route of choosing a black card followed by a second black card, which would give me the probability of 42 out of 132. Now what the question says is, what is the probability you will choose two cards of the same colour? Two cards of the same colour. So what I'm interested in is choosing a red and a red. So I'm very interested in this probability, but also choosing a black and a black. So I'm also interested in this probability. Again, you can see I've highlighted the two routes I'm interested in the probability tree. I'm going to take both of my probabilities and add them together to get my final answer. So I've added my probabilities together, 62 out of 132. We could simplify that down if we wished. So again, a completed probability tree with all four calculations worked out, just making sure I understand that the probabilities at this point will be altered, will be changed depending on what happened on my first event. Okay, so this is the third example that I'm going to talk through. However, you do have the ability to pause the video at this point. So if you want to have a go at the question yourself, you are able to do that at this point. Let's have a go at this third question. There are 7 sweets in a bag. 5 of the sweets are cherry flavour and 2 of the sweets are apple flavour. If you randomly choose and eat 2 sweets, what is the probability you will eat at least 1 apple sweet? Okay, so because we are eating the sweets, that is telling us we are dealing with dependent events. These events are not independent. One is influenced by the other. Your second choice of sweet, the probability will be changed given what happened for your first selection of a sweet. Let's have a look at what that would look like as a probability tree. For the first selection, for your first sweet, we have 2 options. We're either going to choose a cherry sweet, which is 5 out of 7. 5 cherry sweets out of 7 in the bag altogether. Or we're going to choose an apple sweet. 2 apples out of 7 sweets altogether. That's all well and good. 5 and 2 taken from the question, put into some fractions, some probabilities. Again, just double checking your maths. Those 2 fractions add up to 7 out of 7, 1 whole. So the branch adds up to 1 whole. Okay, if we look at the second selection, the second sweet we are going to eat, this is where probabilities will change. So this probability and this probability are altered given what occurred here. So if I ate a cherry sweet for my first sweet, I then have 1 less cherry and 1 less sweet in the bag, which is where my 4/6 comes from. If I was to eat a cherry first, I still have my 2 apple sweets, but I have 1 less in the bag. Alternately, let's say I chose an apple for my first sweet. So I chose an apple for my first sweet. So now for cherries, I still have my 5 cherries remaining with 6 sweets in the bag altogether. And if I did eat an apple, the probability of getting a second apple would be 1 out of 6. 1 less apple sweet, 1 less in the bag altogether. So all of these probabilities for my second event are influenced by what occurred in the first event. So they are not independent events. One is influenced by the other. Let's go ahead and do some calculations. The probability of getting a cherry followed by a cherry is 5/7 multiplied by 4/6. It's going to give me a probability of 20 over 42. Probability of getting a cherry followed by an apple sweet is 10 out of 42. Probability of getting an apple and then eating a cherry sweet second would be 10 out of 42. And the probability of eating an apple sweet followed by another apple sweet would be, let's have a look here, 2 out of 42. Okay, if I was to add up all 4 of these probabilities, again, they would add up to 42 out of 42, which should be 1 whole, or which is 1 whole. Now I go back to the question, and again, a very typical exam question. What is the probability you will eat at least one apple sweet. Very important, this word, at least one apple sweet. So we are looking for when we eat a cherry followed by an apple, because that would be one apple sweet. Also an apple followed by a cherry, because that would be one apple sweet. But also if we have an apple followed by an apple, because even though that's two apple sweets, it is at least one. So you can see the three roots that I've highlighted on my probability tree. So all three of these probabilities are important. They are all going to get added together to give me the answer to this probability question. So I'm going to take those three probabilities, add them all together to get 22 out of 42, which would take me down to 11 out of 21. An alternate way of approaching this question would be, once we realize that these three roots are all the roots that we would like, they are all interesting, they are all involved in my final answer, what I could do is work out the probability of getting a cherry and a cherry, because this is the only route where you do not get at least one apple. And then what I could do is I could subtract that from 1, and I'd get the same answer down here. But for the basis of this question, you were asked to draw a complete probability tree, which is often what you'll be asked in your tests and exams. So this way of showing all three probabilities you're interested in would be the better way of approaching the question for this type of question. Okay. So now it is time for you to have a go at a few questions. So if you're not totally confident with probability trees for dependent events, please rewind the video, go and listen to my examples one more time. But at this point, I would like you to pause the video. For each question, I'd like you to complete a full and accurate probability tree with all the calculations included. And then I would like you to answer the question that is contained in each question. So could you have a go at all three questions? Could you pause the video now, please? Okay, welcome back. So I'm going to talk you through my answers one at a time. So for question 1, John has 10 cubes, 7 of them are purple, and the rest are blue. So there's my two probabilities here. And then our probabilities for my second choice of cube are influenced by what happened for my first choice because of this important wording without replacement. So you can see I'm now dealing with 9 cubes in the bag or in the box because we've already removed one on the first pick. You can see how I've altered the probabilities for the second choice. The question says, what is the probability that he chooses 2 purple cubes? So I'm interested in purple multiplied by purple, which I've highlighted vaguely there. 7/10 times 6/9 is 42 out of 90, which we could simplify down to 7 over 15. This is your completed probability tree with all 4 calculations included, and then you're selecting the calculation answer, which helps you answer the question. Question 2. We're dealing with 12 marbles in a bag. 7 of those marbles are gold. That helps me get this probability here. So I know this probability for silver has to be 5 out of 12 because them two have to add up to 12 out of 12, 1 whole. Again, it's without replacement, very important wording in the question. That's telling me I'm dealing with a dependent event. This selection is influenced by this selection. So if I choose a gold in my first option, I then have 1 less gold and 1 less marble altogether, which is where my 6 out of 11 comes from. I use the same logic to complete the other probabilities. Then the question asks, I want a probability that I choose 1 of each color. So I'm interested in gold followed by silver, because that would be 1 gold and 1 silver, which is 35 over 132. And I'm also interested in choosing a silver first, then followed by a gold, which would also be 75 over 132. Add those two together, 70 over 132, which we could simplify down. So I want one of each colour, which means I'm not interested in gold, gold, and I'm not interested in silver, silver. Third question. So again, this question refers to someone eating chocolates, which is telling me there's no replacement, which is telling me I'm dealing with independent events. 10 milk chocolates out of 14, which leaves me with 4 dark chocolates out of 14. We eat a chocolate on the first pick, which is why I'm dealing with a denominator of 13 for my second pick. Work out all 4 calculations like I've done on the screen. What is the probability that he eats at least one dark chocolate? So we're interested in the 3 roots I've highlighted on the screen. These 3 probabilities we would add them all together to get our final answer of 92 out of 182, which we could simplify down. Remember, you could have worked out the probability that you didn't want, which was milk chocolate followed by milk chocolate, and I could have subtracted that from 182, could have subtracted this fraction from 1 whole, but because the nature of the question asked us to draw a full and complete probability tree, we should be looking at something like this and using these 3 probabilities. Okay. If you would like a little bit more practice with probability trees and working out what calculation you need to do, you can have a go at these 4 questions. So I would like you to pause the video, work through each question, and just be focusing on the calculation that you would need to do after you've produced the probability tree. So for my answers, I will show you the calculation that you should be using, and then you can relate that to your probability tree. Could you pause the video now and have a go at these 4 questions? Okay, welcome back. So I've just displayed my answers there on the screen. For each one, you can see the calculation that you should have been doing after you've drawn the probability tree. So just relate my calculations to the roots and the calculations you have done on your probability trees. Notice that we can be given a probability as a decimal, and we could use a probability tree in the exact same way we've been using for fractions. So the exact same method is applicable when dealing with decimals. We're going to finish with 2 typical exam questions. So for each question, I would like you to pause the video, have a go at completing the exam question, and then I will go through the worked solution and show you where the exam marks would be allocated. So you can see from this question, 3 marks available for question A, 3 marks available for question B. Could you pause the video now and have a go at this question? Okay, welcome back. This is what your working out should look like. So you can see you get 1 mark here for coming up with the probabilities on your first choice of bead, taking the information from the question. And then you're going to get 2 more marks here for using your knowledge of dependent events to alter the probabilities that appear on the second branches based on what occurred on the first branches. So you've got 3 marks altogether for completing the correct probabilities on the probability tree. Then we go ahead and answer the question. You can see the 2 calculations that we need to follow. The calculations are here, and you're looking for 8 out of 72 and 8 out of 72, which we would add together to get your next mark, 16 out of 72, and then your final mark for simplifying your answer to 2/9. Very well done. If you give that question a good go. Question 2, another typical exam question. Could you pause the video, have a go at this question by completing the probability tree diagram, 3 marks available, and also for answering question B, 3 marks available. Could you pause the video now, please? Okay, welcome back. Work out the probability that there are now exactly 3 plain chocolates in the box. So we started with 4 plain chocolates, and question B wants to know that there's exactly 3 plain chocolates left. So that's another way of asking that you want to get exactly 1 plain chocolate out of your 2 choices, because that would take us from 4 down to 3. Your working out should look something like this. Again, 1 mark available for your original probabilities, another couple of marks available for using your knowledge of dependent events in order to work out your probabilities on your second choice, or Alison's choice, which would be the second choice from the tray of chocolates. At the start, there were 4 plain chocolates, and we want to eat just 1 plain chocolate. So we're looking for the roots when it's exactly 1 plain chocolate. So we've got plain chocolate followed by milk chocolate. That would be 1 root, which is this one here, 24 out of 90. And we've also got milk chocolate and then followed by a plain chocolate. So that would be this root here, giving us another 24 out of 90, which we would then add together for another method mark, 48 out of 90, which we could simplify down. Very well done if you were able to answer that exam question. And very well done throughout this video if you've been able to produce some good probability trees in order to answer some difficult probability questions. That is showing a very good understanding of drawn probability trees and understanding dependent events within probability. Very well done.